Hello everyone, welcome back to my YouTube channel. I'm Pallavi. Currently, I'm studying in Sri Venkateshwara College of Engineering from first year, second sem ECE branch. Today's topic is applications of angles and projections. Applications of angle and projections. Angle and projection concepts are fundamental in various areas of mathematics, including geometry, physics, and engineering. These principles have numerous practical applications from navigation and surveying to computer graphic and robotics. Angle measurement and notations. Angles are measured in degree with a full circle equal to 360 degree. Standard angle notations uses the Greek letters alpha, beta, and gamma. Theta 2 represents the angle. Angles can be also be measured in radians, where 1 radian is an angle that subtends an arc equal in length to the radius of the circle. Angle addition and subtraction. Angle addition is the process of combining two or more angles to find a single equivalent angle. Angle subtraction is the inverse operation, where you find the difference between two angles. These concepts are crucial in fields like trigonometry, navigation, and engineering for tasks like calculating turns, rotation, and vector decompositions. Angle multiplications and division. Angle multiplication. Angle multiplication is a multiplying an angle by a scalar value result in a new angle that is scaled accordingly. For example, multiplying a 30-degree angle by 2 yields a 60-degree angle. Angle division. Angle division is a dividing an angle by a scalar value result in a new angle that is reduced proportionally. For instance, dividing a 90-degree angle by 3 gives a 30-degree angle. These operations are useful in areas like computer graphics, where angle need to be transformed to create a different orientations or perspectives. They also have an application in physics, engineering, and mathematics. Projection of vectors onto axis. The projection of a vector onto an axis is a component of a vector that lies along the axis. The projection is a scalar value that represents the length of the vector in the direction of the axis. Projecting vector onto coordinate axis is a fundamental operation in linear algebra and vector calculus with application in physics, engineering, and computer graphics. Projection of vectors onto another vectors. The projection of a vector onto another vector is a powerful concept in linear algebra. It allows you decompose a vector into its component part along the chosen direction, revealing the scalar quantity representing the vector's magnitude in the direction. This projection is a calculated by taking the dot product of the two vectors and dividing by a magnitude of the projection vector. The result is a scalar value that quantifies the parallel component of the original vector. Solving problems with angle and projection concepts. Angle and projection principles are invaluable tools for solving a wide range of mathematical problems. By understanding how to perform angle calculation and vector projection, you can tackle challenges in geometry, physics, engineering, and beyond. For example, projecting a vector onto a coordinate axis allows you to determine its component magnitudes, which is essential for analyzing forces, velocities, and other physical quantities. Similarly, angle addition and subtractions are crucial for navigational problems and structural engineering designs. Mastering these fundamental concepts empowers you to break down the complex mathematical problems into manageable steps, leading to accurate solution. Consistent practice with the angle and projection application will hone your problem solving skills across diverse fields. Practical applications of angle and projection principles. Structural design. Angle projection calculations are essential for architects and engineering to design safe, stable structures that can withstand forces and loads. Navigation and surveying. Angle measurements and vector projections enable precise mapping, tracking, and positioning for applications like GPS, land surveying, and air traffic controls. Third one is computer graphics. Projection of 3D vector onto 2D screen is a core component of a computer graphics, allowing for realistic rendering and perspective in digital environment. Robotics and automations. Angle calculations and vector projection guides the precise movement and orientation of robotic arms, enabling complex industrial and medical applications. Common angle and projection problems and solutions. Finding missing angles. When given a figure with several angles, you can use angle addition or subtraction to determine the unknown angle by applying properties like adjacent angle adding up to 180 degrees. Second one is calculating projection magnitudes. To find the projection of a vector on an axis or another vector, you can use the dot product formula to compute the scalar quantity represent the parallel component. Decomposing vector. Vector projections allows you break down the vector into its components along chosen direction, which is crucially for analyzing of forces, velocities, and other physical quantities. Rotating coordinate system. Angle multiplication and divisions are key to transforming vectors between coordinate systems with different orientations, a common task in computer graphics and mechanical designs. Strategies for mastering angle and projection techniques. Visualize the geometry. Develop a strong mental picture of how angle and vectors relate in space. Sketch diagram to solidify your understanding of a underlying geometrical principles. Practice with real world examples, applying angle projection concept to problem from physics, engineering, navigation, and other domains. Relate the math to tangible applications. Master the fundamental formulas. Thoroughly learn the key equations for a calculating angle sums, difference, projections, and transformation. Commit these to use memory for quick, accurate calculations. Develop problem solving strategies. Learn systematic approach to break down the complex problems into manageable steps. Identify which angle and projection technique to apply in different scenarios. I hope this is helpful for you and thank you to all for watching my video.